guys, Colin here, hope you're well. So today we're going to take a look at an interesting sample that I picked up from the IBM X-Force Exchange feed. If you're not aware of it, you should definitely check out the IBM X-Force Exchange platform. It's a real good capability for open source threat intelligence feeds. And something I picked up on it recently in the last 24 hours was this COVID-19 themed info stealer. So obviously anything with COVID-19 was getting my attention recently. And I thought I'd take a quick look at the malware. And you can see that the IBM platform gives you a list of the key indicators of compromise, hashes, IP addresses, and C2 URL. Bit of an overview as well, which is nice from whoever submitted it. And also it gives a link to a nice blog post from Reason Security, which goes into a bit more detail behind this particular info stealer. So if you take a look at that particular blog post from reasonsecurity.com, from their blog, it's pretty detailed. So it gives you all the hashes and stuff, and I'll link this into the video as well. But you can see here that the malware has a GUI that looks very good and convincing. When running the malware, the GUI window loads, which then polls from the web, and you get this map from the Johns Hopkins University of confirmed coronavirus infections and all the relevant statistics around it, etc. So whilst this is being displayed to the user, in the background, the malware is actually stealing or attempting to steal credentials and other various bits of information from the machine and piping that back off to the bad guys, all the while as well maintaining its persistence within a scheduled task. So the blog post is really good. It's got all of the indicators that you probably need to protect your environment and go hunting and all the rest of it. So I don't really want to replicate any of this work in this video, but what I wanted to showcase to you is the kind of fusion of knowledge of two separate kind of work streams I'm interested in at the moment. So first is malware analysis, obviously, that we're going to look at some malware. But also, I've been doing a lot of work in the bug bounty space recently. I'm working on some kind of pen tester methodology, and in particular looking at reconnaissance. So how to look at web infrastructure and the kind of tools and techniques that you can use to analyze them in a bit more detail. So here in this video, I want to present to you some of the tools and the techniques that I use to investigate, obviously, web applications which are running bug bounty programs, but also you can apply the same methodology to this malicious infrastructure. So we can do a bit of reconnaissance on the bad guys, and we can move closer to knowing who the bad guys are here by some pretty simple reconnaissance, and get a view on, potentially where this malware originated, and some indicators of those. Indicators of compromise, yes, but also indicators of who might be behind the actual malware itself. So I'm going to show you some of that information today, and hopefully we'll know a bit more information at the end of this video. So let's get cracking. So like I said, I don't want to do a massive amount of malware analysis here. I'm just going to basically, I've got the COVID-19 sample here on my in my downloads folder. I'm just going to run Burp Suite, which is going to proxy all of my internet traffic, and is going to give me a nice easy view of network traffic that's being produced from this virtual machine here on Windows. I'm running Windows 7. It's really old, it's really crappy, but it works well for malware analysis for me. I'm also using my other favorite tool, which is Process Monitor. And actually all I'm going to do is just apply a filter to Process Monitor, where the operation is where a process is created. I'm just going to add that in and apply, hit OK. Press Control and E to set sysinternal Process Monitor off and running. And there's a plethora of different tools that you can use as part of malware analysis, right? Certainly from initial analysis point of view. These are the two tools that I will always use by default, and if I want to or need to go deep diving elsewhere, I'll obviously fire up different tools, but for the purposes of this video and this demonstration, this is pretty much all we need to get going. So I'm going to run the sample. We're going to see what happens, because things are going to be shown to us in Process Monitor, and hopefully network traffic will appear in Burp Suite as well. So we double click it, see what happens. We can see a command window fires up here from System32, as you'd expect, and you can see Process Monitor. We have a large number of processes being generated in the background here without us even noticing it from this particular malware, and we can see that actually I get this GUI window pop up as well. The title of the window is corona-virus-math.com, and if you go and check for that, that is parked by GoDaddy at the moment, so there's no content live at that particular domain. However, maybe it's been registered by the malware author, who knows. But actually, what I don't know why, this is probably something to do with the fact that I'm running a crappy virtual machine on Windows 7, but I don't see this nice, pretty map from John Hopkins in this GUI. I think this is where the map is meant to appear. For whatever reason, it's not appearing on my virtual machine, but I don't really give a shit about that at the moment, to be honest with you. But just imagine that that map pops up, and that's what the victim is going to see. But if we close that out or just minimize it for just a second, we can see there's a considerable number of network traffic here in Burp Suite. What I'm going to do is just going to filter the other way around. So I'm just going to start from the bottom here and work our way up to the most recent web request. And you can see here there's a request to a C2 domain here, coronavirusstatus.space, a post request to index.php. So straight away we know the web application is running PHP, which is interesting. And you can see the request here is what looks like a load of nonsense. That looks to be some kind of encrypted data. And we can see that actually my machine is freezing a little bit, probably because the malware is operating and very, very busy in the background. So it's freezing a little bit and not be able to show you the response. It will probably pop up in just a second, but if we click on the response again, we'll see actually, here we go, a large number of what looks to be an encrypted response back to the malware. We can also see some network traffic to ipapi.co, and that is just responding with the IP address of the victim. In this case, I'm using a proxy IP address, as you should all do when you're analysing malware. So I'm using private internet access, and this is based in Switzerland at the moment. And you can see as well, there is some traffic to Telegram. So there is an API request. You can see there's a bot ID, and then there's the key, and then a call to the routine get me on Telegram's API. So you can go read about that, and that is just to check that the token is actually working. And you can see here the JSON response. So you can see that there is a bot name, there's a username, and there's Flask card bot, and various other attributes as well. So that's quite interesting. So we've got straight away some open source intelligence here that we can use, or an indicator that we can use as part of our further analysis if we need to go digging on the web. And we can see that also as well, there's some other GET requests to another domain, which is this arcgis.com, all related to the map stuff that should be actually displaying to me. So this doesn't appear to be too malicious or anything like that. So that's quite good from a network perspective. Let's just put a pause on process monitor. I think we've probably got enough here to get us going. My virtual machine isn't very well the specification isn't particularly high. I've got about a gig of RAM or so on this one, so hence the reason why it kind of chokes a little bit. But you can see there's a considerable amount of processes which are spawned by the malware. And so actually, if you press Control and T, you get the process tree view in Process Monitor, and so you can see the parent-child relationship between the processes. So COVID-19 is the one that we spawned, and we can see the associated command line. So we can see that looks like it generated a sub-process within the app data roaming folder, and then subsequently we saw that command window fire. Well, that looks like it was a bat file, and you can see here that the bat file looks like it launched a self-extracting executable with a hard-coded password, and you can see that hard-coded password in this -p parameter here. And it looks like it's dropped it in the system32 folder. As well as a lot of other activity here. So you can see that executables being spawned subsequently from the temp directory, and then run DLL, timeout, which is probably something to do with the malware sleeping, all the rest of it. I don't really want to deep dive into all of these processes and all of the commands and everything behind it, because the blog post goes into enough detail around that, and I'll leave you to go and read that and read up on it. However, we can have a little bit of a poke around and just see, what kind of stuff is in the temp folder, for example, if stuff still exists. Let's have a look here. Do I see anything? It doesn't look like there's anything left in the temp folder, so let's go back into app data roaming, and we can see there's this hidden folder which is here, and we have a look, and here's this Windows globalization font groups.exe is one of these processes. So you can see that this is an executable that's been written by the parent process, and we can see there's a couple of files here. One's got 0 bytes in it, and there's other 7-zip files. As soon as you see anything 7-zip, just try and unzip it. So we'll just unzip it to a folder here. Here we go. And then there's some files in here that have been zipped up by the malware. First is a JPEG, and we have a look at it, and actually it's a screenshot of my screen. We can see information.txt as well. So this Fiasc card, work, clipper, and stealer, and then we can see that there's a link, a clear text link as well, to go reading up about whatever this info stealer is, and this is probably something to do with the author behind it. And so you can see that the malware has captured a lot of information about my system, video card, memory, keyboard layout, username, etc. It's also got my IP address, which it thinks it's in Switzerland, obviously, because I'm using a VPN. And as well, it's listed out all of the running processes on my machine, as well as Microsoft Office, etc., etc. Oh, sorry, these are the, beg your pardon, the installed components, and then all of the processes that are currently running on my machine, and the various process IDs as well, including itself. So that's really interesting. No doubt this information is being piped back to the malware operators in order for them to determine what to do next. And, profiling my machine. Am I a malware analyst using various tools to analyze the malware, or am I an actual juicy victim? It probably means something to the attacker. And actually, if we see, we could probably have a look in some of the requests to further C2 communications from the malware. If we see here, go back up another post to index.php, we can see actually this post contains a lot more encrypted data. And actually, if you reference the blog post, you'll notice that all of this data is actually just all of this plain text information being XORed by a unique key, which is generated by the malware per victim, and then being posted back to the malware operators at this particular location. So that's what it's doing. It's looking for. You can have a look at your desktop text files. So it's looking at stuff that's on my desktop. It's looking at cookies. It tries to steal all of your credentials from the browser. If you run Telegram, if you've got crypto wallets on your machine, it will try and enumerate those credentials as well and pipe all those back to the bad guys. So pretty serious info stealer. And given the theme of the actual malware, I'm sure it's probably had quite a lot of success in tricking some victims as well. But really, what I want to do, so in terms of our malware analysis, that's as far as I want to take it, and usually, as you know, I'd probably deep dive a bit more into it, but I want to showcase to you now some of the reconnaissance tools that I like to use from a bug bounty pen test perspective, but we'll apply this to this malicious infrastructure in this particular instance. So first thing I want to do is have a look at this domain in RiskIQ. So I really like RiskIQ because it gives some real good open source intelligence related to IP addresses, email addresses, domain names, etc. So we've got this domain coronavirusstatus.space, and if we run a check on that in RiskIQ, we can see the IP address resolutions and the historic resolutions of that particular IP address, and we can see here that currently it's associated to this 104.24 IP address. And in fact, if we ping that particular domain, let me just get rid of all of this stuff. Then we can see it pings 104.24.102.92, which is effectively what we're seeing here. So there's a couple of IP addresses, and if you do a whois on those, you can see here it's tagged as Cloudflare. So the bad guy has put this domain behind Cloudflare protection, so actually you don't see the true IP address of the bad guy, you see the IP addresses of Cloudflare. However, you can see that prior to being registered or behind Cloudflare, you can see that it was associated to this particular IP address here. And if we had a look at this particular IP address, we would see that it's based in Russia. It's registered to, you can see here actually, the domain name registrar reg.ru, and therefore there's some likely indicators that this was registered using reg.ru. The domain name was used to was registered using reg.ru before being put behind Cloudflare. So there's some basic information for you from RiskIQ, and if you wanted to, you can go into a deep dive on the whois, certificates, any associated subdomains, and OSINT, etc. And if you look in OSINT, actually it references this reason security. So RiskIQ does a real good job at stitching all of the open source tooling together and presenting you with a nice clear view on what's going on under the hood here. Also, as well, we can put IP addresses, etc., into Showdown. I'm going to come back to this in just a second because we're going to look at some more interesting information behind this particular domain. So, one of the things I like to do when I'm approaching a target, certainly from a bug bounty or pen test perspective, is to look at all of the other subdomains that might be associated with that particular domain. So, one of the tools I like to use, it's written in Go, it's called Asset Finder, and if you look at the help for Asset Finder, we can look at just subdomains associated to a domain that we're going to pass it as a command. Asset Finder is an amazing tool for finding associated subdomains from various different sources. So if we have a quick look at, if I can type it properly, we'll just do tesla.com. And we can see it'll straight away, it will enumerate and show us all of the associated subdomains for tesla.com, and we can go off and do whatever analysis we want to do around those. In this instance, obviously we want to look at, what am I doing? We want to look at coronavirus status.space. Let me paste this in here. And we can see that actually there are no subdomains associated with this particular domain. So we're just dealing with one root domain here. So we knew from our analysis that it's posting to index.php. So let's copy that URL. Let's just try visiting that in the browser. And perform a GET request. Obviously, it's not a POST request, and we'll just see if it throws up any errors or anything like that. And actually, we see it doesn't really do anything, right? So we just get nothing back in the response or anything. So, so that's pretty bit of a waste of time. But needless to say, it's always worth trying. The other thing I like to do is use a program called dir search, or dir search, however you want to pronounce it. I tend to go with the dir search option. It's written in Python, and it's a tool which will brute force, based on a word list that you provide it, folders and files associated with the domain that you feed it. So this is a super useful tool. It's actually got a pretty lengthy command or command line structure to actually get this thing going. So what I wanted to introduce to you very quickly is the idea of a bash alias to help you kind of speed up your reconnaissance work. So I have a look at my bash profile, which I'm just going to move onto my screen here. So my bash profile is a list of functions which I've written in bash and stolen from various online sources to make my life easier, but just to give me aliases for functions which do a large number of things. So you can see here I have a function called as, which will perform all of these particular commands for me and do whatever it needs to do, and that's part of the reconnaissance that I use for bug bounties. But in here I have also a function called ds, which stands for dir search. I'm not really that creative the way I name things. And dir search does a few things. Firstly, it calls a function called sortdicts, which is sorting some dictionaries. And so what I basically do is concatenate a list of word lists. So one from Tom Nom Nom called config files. I also have my own custom one, which I frequently add to of interesting files that I come across online. Also, there's a default word list from dir search as well that gets installed called dicc.txt. And also, there's a load of really, really amazing word list content from seclists. So you should definitely pull that GitHub repo and have that in your arsenal. So seclists has numerous text files which are really, really useful for us. One's called quick hits. We're going to look for a large list of files, and we're also going to look for a large list of directories, and we're going to concatenate all of those files into one text file here, yolo.txt, and all I'm going to do is sort that. So there might be duplicates across those dictionaries, and we're going to sort it, and so that's going to be the first command to this ds. And then Python 3 dirsearch.py, and I'm going to feed it that word list that I've just created. Then it's going to exclude these particular HTTP status codes. -u $1 just means I'm going to feed it the URL as the argument to whatever I pass ds. So I'll feed it obviously this coronavirus status.space. Timeouts, I'm going to give it a few seconds to time out the connection so we can move on pretty quickly. And I'm looking for a load of file extensions as well. So in these dictionaries, the way that dir search works is that you can feed it a list of file names, and it'll also brute force various different file extensions that you choose. And you can see here that I've defined a rather big list of file names, or file extensions rather, to try with those file names. I'm going to try as many threads as possible, a couple of headers, and then also just going to output to a report here. So that's my bash alias. So we're going to run dir search on. Let me go back to my screen here. So we're going to run dir search, and we're going to run it on coronavirus status.space. So it's going to take a minute. You can see that my word list, because I concatenated all of those words together, is like 116,000 words long. And you can see it's multi-threading the requests. It's making hell of a lot of requests to this particular web server, and you can see the associated output. So lots of stuff is being 403'd, which is probably what you'd expect. Certainly dot files, etc., will probably be as part of the default configuration for web servers. A large number of them will have default configs of just 403, those kind of requests. But you can see that what we're interested in are mainly the 200 or the 301s, 302 responses, to see whether or not any of these interesting files pop up on this particular resource. So we know that there was index.php. But we also know that there's a root directory to this as well. But again, that's as we've just seen here, it's showing 0 bytes of returned content. So not very interesting to us. So we'll let it do the rest of its analysis, see if it pops up with anything interesting. We just scroll up, make sure I didn't miss anything of interest. Everything's 400 or 403, so that's no use to us really. So we'll hopefully see it pop up with some more interesting results shortly. So that's a quick overview on some of the tools that I like to use for reconnaissance. Really, really powerful is Asset Finder. In this situation, we didn't have to use it too much because there was no interesting results from it. But dir search hopefully is going to give us a bit more active reconnaissance into this particular web asset. So you can see about 30% of the way through, you can see that it's making all of these requests, 116,000 requests, and it's going to be pretty quick. So as I said, hopefully we'll get some good results. Let's see what it gives us. Okay, so one of the first things it's popped back with here is a 301 to a folder called CGI bin, really, really common within the web application space. So that's something we want to take note of because we could run dir search again. We know basically that this folder exists on the web server because we're being 301, or potentially exists anyway, and we can see that actually the 301 to CGI bin redirects to CGI bin /, which is then subsequently 403. And we can see that the 403 is 217 bytes of returned content. So we could do that in our browser as well. So let's go to CGI-bin. It will redirect to // and we can see that we have the however many byte content is that we just don't have permission to it. But that tells you that it exists on the web server, so you could then go brute forcing on that particular folder as well. So we'll see if it brings back anything other interesting as well. Bear in mind as well, all of these, just a point for your operational security, is that the bad guys will be able to see the IP addresses that you're generating the requests from in their web server logs. So you definitely want to be behind either a protected VPN or an IP address that you don't really care about them knowing. So we can see here there's index.php again, so we knew that already. So that was just one of the entries in the word list and /login. But you see that the byte content is 0 bytes. So again, nothing really that we're too interested in. So we'll see what else it's going to bring in for us. Nice. Okay, so here's an interesting result as well. So we've got another 301 to panel. Looks like it's another folder. But notice as well, we didn't get a 403 after it either. So if we go to panel, let's see what we get in our browser. Let me go over here. We can see we get a title. Couldn't be translated. Let me see, try again maybe. Translated. There is no database connection. So that's interesting. So we've now got ourselves an error message, which would suggest that potentially there's a database running on this particular endpoint. And we've also got this folder name of panel, which is really interesting to us. And we can see we're 80-90% done. So we're probably not going to get too much more out of this this particular word search. But I think where I'm heading next with the analysis is I want to brute force on /panel and see what files and folders sit behind that particular endpoint as well. So I think that is what we're going to do next. We'll just let this finish. Alrighty, nearly done. these weird requests at the end of my word list. Obviously, because I sorted them, they're all in alphabetical order, so you get the weird ones at the end. Okay, let's stop that. So let's do /panel, hit go, and hopefully we'll see again some interesting results. We use the same word list this time, and you can see, very similar structure, a lot of 403s, but look, we get admin.php and we get 200 bytes returned, config.json. We also get a files folder. We also get an upload folder. So this is starting to look a bit juicy now. So let's go back to our Chrome instance here. Let's go to admin.php. And we can see here, right, we've got a form which takes a password, and we had a look at the source of the HTML here. Nothing to it. It's just simply going to post whatever password that you send in this particular field. So type it a nice little message, see what happens. Okay, nothing. But if you were so inclined, you could probably brute force that password field just to see whether or not there's any additional information behind it. We're going to stop at this point. We're not going to perform that kind of activity. Probably worth just testing out a few parameters, like putting in a few weird characters or stuff which you might think would throw a database error, something like that. So we'll put a few more weird and wonderful characters in there just to see if we can get anything out of it. Doesn't look like we can, but there's a key endpoint for us to go and do some additional targeting on, do some monitoring on as well, and also, more importantly, add that panel /panel/admin.php to your custom word list. So the next time you go looking for malicious infrastructure and do some reconnaissance, add that to your list, because it no doubt will pop up in different malware samples and web applications as well. Let's go back over here. We also had config.json, so let's see what that gives us, which is looks pretty interesting. Probably something the bad guy doesn't want us to have access to, but we'll see if this doesn't look like there's any sensitive information in here. But yeah, so is double, is safe passwords, is browser data, is browser history, is wallet, is Skype, is Telegram. Yeah, that sounds like I think that's something to do with the malware itself. So maybe it pulls down this config for the malware itself, or maybe that's a blank config that gets sent down to the victims. To see what what kind of stuff it wants to steal. I'm not entirely sure, but that's probably what it feels like to me. But again, we've now got a config structure. There's some more information about this particular malware that we didn't see from our virtual machine. So let's go back. Where do we go to? Config. So we've got a files directory, but it's 0 bytes. But that's useful to know, because if you wanted to, you can go brute forcing. And we've got uploads as well. So let's have a look at upload. Oops, that sounds quite interesting. Directory access is forbidden. Yeah, no shit it is. So again, probably something you could then go off and do some additional reconnaissance on. Not going to do it just yet, but I'll leave that up to you to go and poke around. But again, another one of those that is, /panel/upload is probably one of the ones you want to add into your custom word list for next time. Where are we up to? Well, look at this. This looks really cool. Oh, well, we got functions.php. Add that to your list. 0 bytes at the moment, but it's doing this functions.php. It's going to execute on the server. And we've also got this. This looks juicy, right? /panel guest.php and 6 kilobytes of return content. So let's get onto this bad boy and see what we get here. So guest.php. Right, look at this. We got some statistics now. And this actually looks like statistics from the actual malware. So all infection numbers, how many today, how many this week, how many this month, the countries of infections, the architecture of infections, the OS, whether they were admin or standard users. Most people seem to be admin. That's quite interesting. What binary type, don't know what that means. What password type, the types of passwords that have been compromised. So 737 browser passwords, mail clients, FTP clients as well, and also what kind of software was running or able to be compromised. So Google Chrome was probably the predominant browser, Mozilla Outlook credentials, FileZilla credentials, etc. So real juicy information here about how successful this malware campaign is actually being. And again, if you have a look at the source of this HTML, not that it gives us too much information, but some more reconnaissance, right? It's got image folders, it's got image softs, image flags, image win, CSS folders. No doubt it'll have a JavaScript folder as well. Just more folders that you can go and brute force. But look at this. The title of the actual HTML, Azerot. Well, this is Azerot malware, and if you Google this, there'll be blog posts till the cows come home on this particular malware and this C2 panel and all the rest of it. So definitely malware, which seems to be just kind of rebranding Azerot, and this is a key indicator of that particular IOC. So really interesting. Okay, what else have we got? We've also got panel links.txt. This is quite interesting as well. Let me go back into our browser, see if this gives us anything interesting. So links.txt, and it just gives us the string %mail. But this is again, something to add into your word list for next time. And you never know, this might produce something pretty juicy. So we'll see where that gets us. Okay, so that's really cool. Also, just notice though that I ran, a fairly, what I would suggest is a fairly limited word list against this particular asset. 116,000 or so words in my dictionary, and we can definitely fire a lot more stuff at it if we really wanted to. And what I'm going to save you is I do have another word list where I generate quite a lot of noise and content from stitching together pretty much everything that's in sec lists, and it takes quite an amount of time to run it, as you can imagine. But what I will show you is one of the outputs that I found super fascinating. Is going to lead us off into some further analysis here and get us closer to knowing who the bad guys are. Do you remember if we looked in our virtual machine, we knew that this C2 is running PHP. Straight away in my brain, one of the things I really want to look for is the presence of the PHP info page, which is usually simply phpinfo.php. Sometimes it's called info.php, sometimes it's called i.php. I've seen all sorts of variants of it, but the standard kind of the default naming would be phpinfo.php, and I try it on every single endpoint that's running PHP in every single folder as well. So let's just see if we get it. So phpinfo.php, guess what it's going to return to us? Because obviously it wouldn't be a good video if it didn't have this information, but hopefully it's going to return to us all of the juicy information associated with the PHP installation on this particular server. Why am I getting so excited about this? Because it's just a PHP version page. Well, firstly, you get the version of PHP, and you can do some reconnaissance to see whether or not there's any vulnerabilities associated with that particular version. If this was a bug bounty program, I would definitely submit this endpoint, solely for the fact that a lot of bug bounty programs will see this as a leakage of sensitive information, because you can profile a lot of information about what's running on the system just by having access to this page. And realistically, this should be blocked. A lot of bounty providers don't pay out on this kind of information because they see it as like, yeah, it's fairly sensitive, but you can't really do anything with it. But it gives you access to knowing it's a massive page of information. Look at all of this stuff that's on here. It gives you information about the versions of the various plugins that are running, the installation paths, and all the rest of it. And that can give you a real good view as to whether or not an asset is running some vulnerable architecture that you can then go off and exploit. So it could be like a pivot into a more serious issue. In this particular case, the reason why I'm excited, look at this loaded configuration file, home directory, and we have the username. JGalt. So we've now already got closer to the bad guy, and this is, nearly as far as we're going to get to knowing who the bad guy is. We know the username that they were using on the server that deployed PHP to run this particular instance. So we've got this JGalt username, and we can use that, perform some open source, or even if you're that inclined to do some closed source intelligence on this particular username, put a watch on it, put a monitor on it, and start looking for any other associated indicators. But that's a key piece of information for us in terms of the malware operators operational security. That's a big fail in order to give us their username that they logged into the machine with. We can also get the host. So we can see here that the system is being hosted on this particular host name. So fapcode.host. So if we have a look at that in the browser as well, Let's just see where that takes us, and we can see we're at a login page here. And if we do a little bit more analysis, we'll find that actually is a hosting provider in a particular country. We'll see in just a second. We can see all of the INI files that have been parsed by the PHP parser, but the key really information is that username. If we go, there's so much information in this, like all of the plugins, what's enabled, what's not, and all of the config around the PHP environment and image magic and blah blah blah, memcache, etc. If we get right down to the bottom, we get down to the juicy bits of information, just a little bit above all of these credits. We can see the PHP variables. This is what I love. So the username, jgalt, we already knew that, and that's significant information. We can see, the folder structure of where this page lives on the server. So it's in a sites folder, in his home directory. And more importantly, right, we can see the remote address. That's my IP address from Switzerland. In fact, if we did a quick who is on this, we would see that the Swiss IP that I'm using. So that's me. The server port is 80. The server port address, remember we saw here that the resolution was to reg.ru and then it was to Cloudflare. Well, this has given us the server IP address, the true IP address of coronavirusstatus.space. This is the host IP address. And so if we have a look at, we can see here, we're at the default page for this particular web server. We're at the true identity hosted by BrainECP. And we can see here that actually this FAP code.host is BrainECP. So who are they? No idea. But this, again, is all kind of great analysis for you to go off and target. If you're a law enforcement, you could approach brainecp.com, ask for the subscriber information if they're willing to provide it around this particular domain, and do some further analysis on that, obviously to catch the bad guy. But this is, BrainECP is a control panel for hosting web content, much the same as GoDaddy or whoever else. So this is who they're using. This is the true IP address of the actual malware operators. Again, major fail with respect to their operational security here. And you can see that the rest of the references to Cloudflare, etc. So we should be presented with the Cloudflare IP address, but we're not, because we can see this page. So we've got a lot closer to the bad guy. And if we have a look at this IP address in Shodan, now this is, a shared IP address, right? An IP address which is a hosting provider, which no doubt runs a lot of virtual hosts. So we can see the same FAP code.host, and look where it's looking to be based, right out in Bulgaria. So we've now got some more juicy information about this particular malware by using some very basic reconnaissance tooling. So looking at Asset Finder, looking at dir search. We've got some statistics on the victims. We've got some stats on the data that's been harvested. We've got the real IP address of where the C2 is being hosted. We've got the underlying services that are and plugins that are running on the web server. And more importantly, and foolishly, we've managed to get the username of the bad guy that's on the box. So that's pretty much all I wanted to show you. Some real cool techniques, hopefully, that you can use in your own environment, and more importantly, build on. I'd love to know if anyone else gets any more successes in this kind of stuff. So please share your comments and your experiences in the comments of this video, and I look forward to engaging with you all soon. Cheers, bye.